Good morning, students. Now we will discuss about DC ammeter. DC ammeter. In our previous section, we have discussed we have discussed basic meter movement, and now the basic meter is converted into DC ammeter by making a small modification on that. That is simply, here is the point we have to remember is that the basic meter is converted into an ammeter. The basic meter is converted into an ammeter by adding adding a shunt resistance to the basic meter. That means simply by adding a shunt resistance to the basic meter, then it will becomes a meter. Very important point. The basic meter is converted into an ammeter. An ammeter simply by adding a shunt resistance. Shunt resistance should be added to the basic meter. Then just here is the basic meter representation will be done like this. Here it is the basic meter. It is the basic meter representation. Here it is plus and minus. Here Rm is nothing but internal resistance of the meter, or we may also call it as meter resistance or internal resistance of the meter. And the current flowing through this one is Im, that is meter current. Meter current. Now it is the basic meter. This basic meter is converted into a meter by shunting a resistance. Shunting means we have to add a parallel resistor. Parallel, that means for this one I am adding one parallel resistor like this. Parallel resistor. It is the basic circuit for DC ammeter. Here I am naming this one as ISH is the current flowing through this one. That means the current flowing through the shunt path is ISH. Shunt current. Shunt current. And we can represent here RSH or RS. In any one of the manner we can represent. Rs or Rsh is this name, and Ish is the current flowing through this resistor. Im is the current flowing through the meter. Then total current in the circuit is I. I is the total current in the circuit. So with this, now I can calculate how much amount of resistance should be added in parallel with the meter to convert this basic meter into an ammeter. For that, we have to make a simple analysis. Just here, these two branches, look at here, these two branches are parallel to each other. Parallel to each other. Then we know that in case of parallel, in case of parallel, voltage is constant. Voltage is constant. That is the point we have learned previously. In case of parallel connection, voltage is constant. That means voltage in this path is equal to voltage in this path. That means these two voltages are equal. That means now I am writing this one as here VSH. That means voltage at shunt path. This path is equal to VM. That means voltage in meter path. These are the two voltages. And according to the Ohm's law, we know that V equal to I into R. Now coming here, VSH I'm writing as in this path VSH. What is the value of I here? Here it is ISH and R value is RS. So I'm writing this one as ISH into RS is equal to VM is nothing but voltage at this branch. That the basic formula is I into R. The value of I in this path is IM. The value of R in this path is RM. So now I need this value, RS value I need. Then RS is equal to IM into RM divided by, here I'm letting this one to this side, ISH. This much of resistance we need to convert any basic meter into ammeter. Now this value of current ISH can also be written as, look at here from the figure, I can be written as ISH plus IM, the total current. I equal to ISH plus IM, because these two branches are in parallel. So in parallel branches, the current will be split equally. So the sum of this current is equal to the total applied current I. So I equal to ISH into IM. Then ISH can be written as I minus IM. This ISH, this ISH can be written as I minus IM. So I'm substituting this value here. Here I'm substituting. So finally I'm getting RS is equal to IM into RS by I minus IM. It is the value of multiplier resistance. This RS is called as multiplier resistance, and Im is the meter current, I is the total applied input current. I is the total applied input current. Sorry, here it is Rm. R. This is the point regarding to DC voltmeter. Sorry, DC ammeter.